Hello everyone, today we're going to have a look at some examples of using projectile motion and applications of projectile motion, and specifically we're going to have a look at finding the Cartesian equation of the motion of an object and a projectile. So question number 3 from the exercise is saying that a particle is projected from the origin with an initial velocity vector 3I plus j. So what that is telling me is that its initial speed, well, if we want to draw what that vector is representing, we've got 3 here and 1 here. So the initial speed of that particle is going to be the square root of 3 squared plus 1 squared, which is going to be the square root of 10. So the initial speed is the square root of 10 meters per second. Part B. Show that the parabolic path has parametric equations x is 3t and y equals t minus 5t squared. So remember, with these questions we can only start with those things that we know are fundamentally true, and we usually work in the x and the y direction individually. We first of all know that x double dot is always equal to 0. Our horizontal acceleration is always 0, ignoring air resistance, and our acceleration due to gravity is minus 10. We're then going to integrate, and we're going to say x dot is equal to some constant c, and y dot is equal to minus 10t plus some constant c. Now we need to evaluate and find what the value of the velocity is at time equals 0. So we know that when time is equal to 0, x dot is equal to, and we're told that its initial velocity in the x direction is 3. So that means my c, my x dot, is 3. Now we know that when t equals 0, my y velocity is 1. We're told that in the question. So that means 1 is equal to minus 10 times 0 plus c. So 1 is equal to c. So my y velocity vector is minus 10t plus 1. And I'm going to integrate one final time. If I integrate 3, I get 3t plus c, and if I integrate this, I get minus 10, so minus 5t squared plus t plus c. But it's projected from the origin. The question tells us that. So we would know when t equals 0, the origin x equals 0, and when t equals 0, y equals 0. So that means 0 is equal to 0 plus c, so c is equal to 0, which means that x, or c, is equal to 0, which means x is equal to 3t, and up here it's going to be 0 plus c is equal to 0. So that means c is equal to 0, which means y is equal to minus 5t squared plus t plus c, which I believe is prove what we were asked to prove. T minus 5t squared, yep, oh sorry, we agreed that the c was equal to 0, so yep, t minus 5t squared, good, and 3t. Beautiful. Part C asks us to find the parabolic equation, or the Cartesian equation of this curve. To do that, we always are going to make t the subject of our x, so t equals x on 3, and we're going to substitute it into there. So y is equal to minus 5 times x on 3 all squared, plus x on 3. Now, that's going to be x on 3 minus 5 on 9 x squared equals y. Now let's have a look at what we were trying to prove. We can see they've got a 9y here, so let's times everything by 9. 9y equals 9 divided by 3 is 3, 3x minus 5x squared. Done, and that's what we were required to prove. Okay, part D. Find correct to one decimal place the direction of motion when x is 0.15. Now, direction of motion, really what it means, is it going up or is it going down? So, part D, we're trying to find the direction of motion when x equals 0.15. So when x equals 0.15, we might go ahead and find what y is going to be. So y is going to equal 0.15 on 3 minus 5 on 9 times 0.15. squared, sorry. That gets me y 0.0375. But it does ask for the direction of motion, so we need to figure out if it's going up or down, and we should figure out what that theta is going to be. Okay, so we need to find its velocity, and its velocity vector is minus 10t plus 1. So x dot, well, it's always x dot and y dot. These are our velocities. Minus 10t plus 1. And our x dot vector is 3. So x dot is 3. Now that actually, I think I've forgotten a t somewhere. No, x dot is 3. That does make sense because our x velocity is always constant. Now, to find the direction of motion, we need to go, okay, theta is there, our 3 is going to be there, and our y dot is going to be there. But we don't actually know y dot. And to figure out y dot, we need to know the time at x equals 0.15. So we do know that our x equation that we've derived was 3t. So 0.15, which is this x coordinate we're concerned with, 0.15 is equal to 3t, which means that when x is 0.15, the time is 0.05. We're going to substitute that into my y dot equation. Minus 10 times 0.05 plus 1. And that gets me 0.5. So what we've just figured out is that at that particular time, my x velocity is always 3, and its y velocity is a positive number, positive 0.5. So that means tan of theta is equal to 0.5 on 3, which means theta is tan inverse of 0.5 on 3, which is 9 degrees 28 minutes. So my direction of motion is it's in 9 degrees 28 minutes from the horizontal. Okay, the second part of these questions are going to be a lot easier because we're given time. Time is 0.15. So part 2, well, we know x dot is always 3, and y dot we've decided is minus 10t plus 1. So at x equals 0.15, or what t equals 0.15, plus 1. Let's figure out what that is. Minus 10 times 0. Plus 1. We actually get minus 0.5. So now it's actually going down. So we need to find this theta here. That's 3, and that's negative 0.5. So theta is going to equal tan inverse of 0.5 on 3, which is 9 degrees 28 minutes, the same as last time, but it's negative because we're going down. We can tell we're going down because we've got a negative here. Okay, question 4 in the exercise is telling me that an object is tossed from the top of a 20-metre high tower with velocity 5i. If the point of projection is the origin, find the Cartesian equation of the object. Now, initial velocity of 5i is actually telling me, well, I is the x direction, so it's 20-metre high tower, but it's actually just getting tossed straight out. There's no j component, which is your vertical component, and we don't know its angle. Is 0, and we also know that is 5. So its velocity is 5 meters per second. Okay, so now we're going to now we're going to try and figure out the Cartesian equation. Now this question specifically says that the point of projection is the origin. So we're going to assume that this point is 0, 0. Normally, how I've shown you to do it is to assume that this is 20 meters above the origin. But in this instance, it's going to be a bit different. So let's start. We've got our x and our y, and we're going to do these separately. Okay, x double dot is always equal to 0. Y double dot is equal to minus 10. Integrate, we get x dot is equal to c. And at time equals 0, our c, which is our direction in this velocity in the x direction, is 5. So that's going to be 5. Please, though, in an exam, show that you've written this substitution when t is equal to 0, x dot is equal to 5. Therefore, c is equal to 5. If we integrate this, we get y dot is minus 10t plus c. But in this instance, our c is going to be 0. So let's write when t equals 0, y dot is equal to 0. That's because it's being shot straight out. We'll integrate one more time. X is equal to 5t. Y dot is equal to minus 5t squared plus c. Now this c, in fact, is going to be 0. And that's because when t equals 0, y equals 0, because we're told it's projected from the origin. In this instance, t equals 0, x equals 0, therefore c equals 0, because again it's projected from the origin. So my two equations are x equals 5t and y equals minus 5t squared. Right, and we need to find the Cartesian equation. We're going to make t the subject of this, so t is x on 5, which means y is equal to minus 5 times x on 5 all squared, which what's going to be 1 on 5. So x minus x squared on 5. That's my Cartesian equation there. Part B, find how far the object lands from the base of the tower. Okay. Now again, this question is different to how I've actually taught you, but the question is telling you to do it this way, so it's important we know how to do it this way. Obviously, when it lands on the ground, that's going to be when y equals 0 normally. But in this instance, we have set this to be the origin, which in fact means when it lands on the ground, y is going to be minus 20, because we've gone 20 below what we've set the origin to be. So instead of saying 0 equals minus x squared on 5, we're going to say minus x squared on 5 equals minus 20, which means x is going to be 10, the square root of 100. So it lands 10 meters away from the base of the tower. Part C, find, direct to the nearest degree, the direction in which the object is travelling when it hits the ground. To find the direction when it hits the ground, we need to find its x and y velocities. We know from our equations that x dot is equal to 5, and y dot, I think we said, was minus 10t. Now to find my x and y velocities, well, we already know its x velocity. It's a constant 5, but we need to know the time at which it hits the ground to find its y velocity. Now we know an equation for x is equal to 5t. We derived that. Now, the moment it hits the ground is going to be at the same time that it's at x equals 10, because we've decided it hits the ground at x equals 10. So we're going to say 10 is equal to 5t, which means it hits the ground after 2 seconds. So we're going to substitute that into my y velocity and say y dot is minus 10 times 2, which is minus 20. So the second it hits the ground, it's going to have a velocity of x is 5 and y is minus 20, or just y is 20, which means theta is going to be 10 inverse of 5 on 20, or 20 on 5, sorry, which is 75 degrees, 58 minutes. But a negative y velocity means it's moving down, so it's a negative direction. So negative 75 degrees, 58 minutes. Yep, that's all we had to find. Let's have a go at the next one. A particle is projected from the origin with an initial speed v at an angle of theta. We may assume that that is the equation of its path. Show that the horizontal range is that. The horizontal range of a particle means when is my y 0? When does it hit the ground? So we're going to set this to be 0, x tan theta minus gx squared sec squared theta on 2v squared. Have a go at arranging this. So we're going to have gx squared sec squared theta on 2v squared equals x tan theta. Let's kill an x. There we go, that dies there. So we might say g sec squared theta, we've got an x there, equals 2v squared tan theta. Now, horizontal range obviously means that's an x distance, so we're trying to rearrange this for x. So x is going to equal 2v squared tan theta over sec squared theta. Now you might be thinking, okay, there's a couple ways we could go around this. There should be a g there, sorry. We might think, oh, 1 on sec is cos. So let's do that. This is 2v squared tan theta cos squared theta on g. But tan is sine on cos. So this is 2v squared sine theta on cos theta times cos squared theta on g. So we can kill one of those with one of those. And here we've actually got 2 sine theta cos theta, which is sine of 2 theta. So this is x is equal to, because this here, 2 sine theta cos theta, is sine of 2 theta. So we've got v squared sine of 2 theta on g, which is what we were trying to prove. All right. Part B, if the initial speed is 30 and the horizontal range is 75, find the two possible values of theta. So initial speed is 30, so v is equal to 30, and we are told that the horizontal range is 75, so x is equal to 75. Now we also need to realise that to find a value of theta, we also need to assume that gravity is 10. So 75 we're going to say is equal to 30 squared sine of 2 theta on 10. So we're going to rearrange for sine of 2 theta. So 750 on 30 squared is going to be 5 on 6. So sine of 2 theta equals 5 on 6. We're then just going to find sine inverse of that. So that means 2 theta is equal to sine inverse of 5 on 6, which is 56 degrees 26 minutes, or 180 minus 56 degrees 26 minutes. So 180 minus 56 degrees 26 minutes, we get 123, and we're going to divide that by 2, so that's 61 degrees 47 minutes, or 56 degrees 26 minutes divided by 2 is equal to 28 degrees 13 minutes. And those are our two answers. Okay. Question 5 of this exercise is, a ball is tossed from the origin that is 6 metres above ground level. The initial velocity is 24 metres per second at an angle of 30 degrees above the horizontal. Again, let's draw a picture. So we're 6 metres above the ground and we're firing at an angle of 30 degrees at a velocity of 24 metres per second. Again, you don't have to draw a picture. I always do. It makes me feel more comfortable. I feel like I understand what the question is asking me. Now we need to find all of those things, which is just that process that we've been doing in individual directions, so x and y. We might decompose our velocity over here, so 30 degrees 24. Our x velocity is always going to be 24 cos 30. Now cos 30 is root 3 on 2, and 24 times root 3 on 2 obviously is 12 root 3, and then this one, sine of 30 is a half, so that has to be 12. So let's start again. So x double dot is equal to 0, and y double dot is equal to minus 10. Integrate both sides, we get x dot is equal to c, and we're going to say, okay, when t equals 0, x dot, we've just figured out, is 12 root 3, so therefore c is equal to 12 root 3. So this is 12 root 3. We probably should add in that step there, just for our examples. X dot is equal to C. And obviously in an exam, you need to do that. You can't just be doing what I've been doing for your solutions and skipping that step. I'm only skipping that just to save myself time when I do answers for you. Integrate both sides here. Y dot is minus 10t plus C. Now we know when t equals 0, we've just figured out that y dot is equal to 12. We've just figured that out there, which means c is equal to 10 times 0 plus 12, which is 12. So therefore y dot is equal to minus 10t plus 12. Integrate one more time. X is going to be 12 root 3t. Y is equal to minus 5t squared plus 12t plus c. Now we know when t equals 0, x equals 0. And that means 0 is equal to 12 root 3 times 0 plus c, so therefore c is equal to 0. And over here, when t equals 0, we're told in the question that it's initially 6 meters above the origin. So that means y is equal to 6. So 0 plus 0 equals c, but that's a 6 there, so 6 equals c. So therefore, the Cartesian equation, the two x and y equations are 12 root 3t, and y is equal to minus 5t squared plus 12t plus 6. Right, we've just answered question A. All of our equations are there. Obviously, in an exam, you'd probably want to underline or state those at the end that you've done all of what was asked. Now we've got to find the Cartesian equation. Same process. These questions, again, it's literally the same process every single time. We're just making these equations and then manipulating them somehow using our knowledge of the question, maybe our knowledge that when y dot is 0, that's our maximum. Pulling all of those things together, we can see that usually it's the same process every time for these questions. Let's have a go at rearranging for t. So t is going to equal x on 12 root 3. Now if we rationalize the denominator, it's going to be root 3 on 12 times 3, which is 36. So I think that's going to be root 3 on 36. Just going to quickly check that on my calculator. 0.08, root 3 on 36. Yep, so that means t is equal to root 3x on 36. Let's have a go at putting that into my equation. So y is equal to minus 5 times by root 3x on 36, all squared, plus 12 times root 3x on 36, x plus 6. Now if we square root 3 on 36 and times it by 5, we get 5x squared on 432, and then 12 on 36 over here, 12 on 36, is 1 on 3, so we're going to have plus x root 3 on 3 plus 6, and that's all equal to y. Let's just check if that's what we were trying to prove. Oh, it's not. Y is root 3 minus 5 on 432. Let's have a look what's gone wrong there. Oh, there should be a minus there. So 1 on root 3x. 1 on root 3x minus 5 on 432x squared. Plus root 3. So we've got a plus 6 on the end. I think why this is different to what the answer I've gotten is because they have set this to be the origin rather than saying it's 6 meters above. So I guess I would mark this correct because I have taught you to plus the 6 on the end. But if you don't want to plus the 6, you just have to treat the origin at y equals minus 6. Okay. So we've found the Cartesian equation, and we're told if d is the horizontal distance that the ball has travelled when it strikes the ground, show that this equation is true. Okay. So what we need to do is realise our Cartesian equation in parameterized form are these two things here. So let's copy that. I'm going to put it down here. And we need to know, okay, what's happening when I am at that distance d. So d is equal to 12 root 3 t, which means t is equal to d on 12 root 3. We probably should rationalize that denominator, which I think we've done before. So d root 3 on 36 is equal to t. And we're going to substitute that in. Actually, I think it might be easier if we scratch that, and we might substitute that into our Cartesian equation. So we know that y is going to be equal to 0 at that displacement, and we're told that x is equal to d. So we're going to say 0 is equal to minus 5 d squared on 432 plus d root 3 on 3 plus 6. We might have to do quite a lot of times in here. I'm just going to quickly check whether 432 is divisible by 3, which it is. So I think it's best to times everything by 432. So minus 5d squared plus 432 on 3 is 144d root 3. And then 6 times 432 is plus 2592. Okay. And yep, that's what we were trying to prove. Let's plus everything the other side. So 5d squared minus 144d root 3 minus 2592 is equal to 0. Done. And did we have to find that? Yep, find the value of d. So nice and easy there. We're just going to use the quadratic formula. So d is equal to 144 root 3 plus or minus the square root of 144 root 3 squared minus 4 times 5 times minus 2592. Square root that, we get approximately 337.71 over 2 times 5, which is 10. So d is going to equal 144 root 3 plus 337.71 over 10. So I get 58.71 is our answer there. So the distance is 58.71 meters. Okay, this next question is coming from the other exercise that I've set on projectile motion, which comes from New Senior Mathematics. So we've got a particle is projected with a speed of 100 meters per second from a horizontal plane at an angle of 60 degrees. Now we're told that its velocity vector is 100 cos 60i plus 100 sin 60 minus 10t in the j direction. Part A, we've got to find when the particle is at its greatest height. We hopefully should know that its greatest height occurs when its y velocity is 0. And its y velocity vector, we're told, is 100 sin 60 minus 10t. Let's make that equal to 0. We're going to get t is equal to 10 sine 60. Now sine of 60 is root 3 on 2, so that's going to be 5 root 3. So that's when it reaches its greatest height. Okay, part B, we've got to find the position vector. Now the position vector is the integral of velocity, and we're told in the question that its velocity vector is 100 cos 60 I plus 100 sin 60 minus 10t in the j direction. Let's have a go at integrating that. So r of t, the integral of 100 cos 60 is going to be 100 cos 60t. Please don't think you have to integrate sine, cos, or tan in these questions because they're just constants, because theta is not changing. It's just a constant angle of projection. And if we integrate this, we're going to have plus 100 sine 60t minus 5t squared j. Now we might state that when t is equal to 0, x is equal to 0 and y is equal to 0. And that's just saying that all of my constant c's when we integrate are going to be 0. And that's because we're starting from the origin. Okay. Part C, the greatest height reached. Well, the greatest height is going to be, we know that y is equal to 100 sine 60t minus 5t squared. And we know this occurs at 5 root 3. So 100 sine 60 times 5 root 3 minus 5 times 5 root 3 all squared. And that equals, type it into our calculator, 100 sine 60 times 5 root 3 minus 5 times 5 root 3 all squared. We get 375. Part D, it's time of flight. Again, time of flight is, in other words, saying what time is y equal to 0. So we know that y is 100 sine 60 t minus 5t squared. And we're going to set that equal to 0. So that means t is going to equal 50 sine 60, which is 25 root 3, I think. Yeah, 25 root 3. No, that doesn't seem right. 100 divided by 5, sorry, is 20. So this is 20, which means that's 10 root 3. Now, the reason I knew that that wasn't quite right there is because this is being projected from the origin, which means that its displacement, its maximum displacement is going to occur at double the time of maximum height, and that's because the parabola is symmetrical. Part E asks for the horizontal range. We know my equation is 100 cos 60t, cos 60t, and that's equal to x, and the time is 10 root 3, so 100 cos 60 times by 10 root 3. 100 cos 60 is 50 times 10. It's going to be 500 root 3 meters is my horizontal range. Okay. The last part is the equation of trajectory. So we know a couple things. I might copy that down here. Now we might, so that means y is equal to that, or not y, sorry, this is equal to r of t. And we need to make one Cartesian equation. We're going to do that by making x the subject of, or t the subject of my x equation, so 1 cos 60t. And we're going to substitute that up to here. So that means we've got y is equal to 100 sine 60 times by x on 100 cos 60 minus 5 times by x on 100 cos 60 squared. So that will cancel with that. That will become x tan 60 minus 5 on 100 squared is 1 on 2000 cos squared 60 x squared. Now tan of 60 is root 3, so this is root 3x minus cos of 60 is a half, and a half squared is a quarter, so 2000 times by 1/4 is 500, so x squared on 500. Okay, the next question we're going to have a look at is question 19 of the exercise. And it tells me that a stone is projected horizontally with a velocity of 15 meters per second from the top of a building that is 30 meters high. So I've drawn a picture there. Remember, when you're projected horizontally, that means that its y velocity is 0, which means its angle is also 0. So if we go in the x and the y directions, first of all, x double dot is equal to 0 as always, and y double dot is equal to minus 10. If we integrate, we get x dot is equal to 15, and y dot is going to equal minus 5t squared, and that's going to be plus 0, because our c is 0 because it doesn't have a y velocity. If we integrate a second time, got x is 15t, and y is going to equal minus 5t squared plus 30. That's because we're 30 meters above the origin. Now we might just state that when t is equal to 0, if we want to state why that's happened, I'm going to say y is equal to minus 5t squared plus 30 plus c plus, sorry, not plus 30 plus c, and that's because when t is equal to 0, y is equal to 30. So therefore my velocity equation is going to equal 15I plus minus 5t squared j, and my displacement equation is going to equal 15ti plus minus 5t squared plus 30j. Okay. At the same instant, another stone is projected from the base of the same building with a velocity of 30 meters per second at an angle of 60 degrees to the horizontal. So we've got this same picture here, but we've also got a stone being projected, and we're here at an angle of 60 degrees, and it's being projected at 30 meters per second. So what we might do is figure out the equation of projectile 2, so in the x and the y direction. So x double dot is going to equal 0, y double dot is minus 10. Integrate x dot is equal to c. If we want to have a go at decomposing this velocity, we've got 60 degrees there, 30 there. You might move that up to there. Now cos of 60 is root 3 on, is a half, sorry. So this is going to be 15. And sine of 60 is root 3 on 2, so this is going to be 15 root 3. So x is equal to c. We know though when t is equal to 0, x dot we've just proven to be 15. So that means x dot is equal to 15. If we integrate over here, y dot is going to be minus 10t plus c. However, we know that when t is equal to 0, we've just shown that y dot is equal to 15 root 3. So that means y dot is going to equal minus 10t plus 15 root 3. Integrate one more time. X is going to equal 15t plus c, and y is equal to minus 5t squared plus 15 root 3t plus c. Now we know that when x is 0 when t equals 0, which means c is equal to 0. But we also know that when y is equal to, or when t is equal to 0, y is equal to 0, because this second projectile is being projected from the ground. So my two equations are x is equal to 15t and y is equal to minus 5t squared plus 15 root 3t. So what I've just done is, we need to find expressions for v2t and r2t. So that means v of t for this one is going to equal 15 I plus minus 10t plus 15 root 3j, and the displacement vector is going to equal 15t I plus minus 10t plus 5, or 15 root 3 in the j direction. Now assume we're going to have to find when these two particles collide. If the coordinates of the base are 0, 0, find the coordinates of the point of collision. Okay, what we might do is we might copy down onto a new page my two displacement equations. So that's the first one, and my second one, sorry, that's the second one. Where's the first one? Here. Okay. And what we're trying to do, I think I've got one of those wrong. Sorry, that's wrong there. That needs to be minus 5t squared. And then that's going to be a t there. So minus 5t squared plus 15 root 3t. Okay, and we're trying to figure out when these intersect. So obviously they're going to intersect at this when the x and the y coordinates are the same. So we need to set them to be equal to each other. So let's set our y coordinates to be equal to each other. We're going to say minus 5t squared plus 15 root 3t equals minus 5t squared plus 30. Obviously these are going to cancel, and we're going to have 15 root 3t equals 30, which means t is going to equal 2 on root 3, which is 2 root 3 on 3. So t is 2 root 3 on 3. All we need to do now is set that to be the time in one of our equations. So x is going to equal 15 times 2 root 3 on 3, which is 30, which is 10 root 3. And y is equal to minus 5 times 2 root 3 on 3 squared plus 30. So 2 root 3 on 3 squared times by 5 is minus 20 on 3 plus 30. And that gets me 70 on 3. So therefore my coordinates are 10 root 3 and 70 on 3. Okay, thank you.